Hello and welcome. Today we are going to look at how we can find enthalpy of a given reaction if at all we have been given the enthalpy of formation of the compounds. So, enthalpy of a reaction, basically we shall use the difference between the total enthalpy of formation of products and the total enthalpies of formation of the reactants. Let's take a look at a general equation whereby A and B are our compounds and they are reacting to form C and D. However, the small letters A, B, C and D are whole numbers which could be 1, 2, 3 and so on, depending on how you have balanced the equation. So let us see the general formula that we can use to find enthalpy of a given reaction if at all they have given us enthalpy of formation of A and enthalpy of formation of B together with C and D. So enthalpy of a reaction, like we have said in the definition, we shall use the total enthalpy of formation of the products minus the total enthalpy of formation of the reactants. This expression obviously comes from Hess's law. You can use Hess's law, but still you will be meaning the same thing as this simplified equation. So when we go back to our general equation where A and B react to form C and D, then balanced with these whole numbers A, B, C and D, we shall see that the enthalpy of the reaction, this reaction here, will be given by the enthalpy of formation of the products, which is C and D. So this is enthalpy of formation of the product C multiplied by the coefficient that we have used to balance C plus the enthalpy of formation of D multiplied by the coefficient that we have used to balance D. Then minus the enthalpy of formation of our reactants A and B, enthalpy of formation of A multiplied by the A, then plus enthalpy of formation of B multiplied by B. However, one thing to note is that if A and B are actually elements in their standard form, their enthalpy of formation is considered to be 0. For example, oxygen is a gas in its standard form, so enthalpy of formation of oxygen from oxygen is considered to be 0. And the same applies to other elements that will occur in the same nature. So let's look at some examples and see how we can apply this general expression to obtain enthalpy of a reaction. So we have a chemical equation for the combustion of methane, CH4, this one here. We want to find the standard enthalpy change of combustion of methane using the values of enthalpy change of methane. So they have given us the values of enthalpy of formation of methane. For oxygen, we shall find it out. They have given us for carbon dioxide. They have given us for water. So we are going to use our expression that our enthalpy change of reaction, actually in this case will be combustion, enthalpy change of combustion, let us maintain reaction. So enthalpy of combustion of our methane will be equal to, obviously we are going to look at the enthalpy change of the products minus the enthalpy change of the reactants. Remember, here we had seen that we are going to use enthalpy change of formation of products minus enthalpy change of formation of reactants. So our products are carbon dioxide. So we have 1 mole of carbon dioxide. So basically we have the enthalpy change of formation of our carbon dioxide plus twice the enthalpy change of formation of our water. Then this will be minus the enthalpy change of formation of the reactants. So we have our methane, enthalpy change of formation of our methane, then plus the enthalpy change of formation of oxygen, twice the enthalpy change of formation of oxygen. However, before we go any further, we know that oxygen, the enthalpy change of formation of oxygen from oxygen is 0. So basically the whole of this is 0. So we shall ignore, that's why it wasn't even given to us under this data here. So enthalpy change of formation of carbon dioxide is minus 393.5 kilojoules per mole plus twice the enthalpy change of water, which is minus 285.8. So this is the enthalpy change of formation of our products. Then minus enthalpy change of methane, which is negative 74.4 plus 0 from oxygen. So when we press the calc, we shall have 965.1, then minus 74.4. So what do we get? 965.1 minus 74.4. We shall get negative 1399.5 kilojoules per mole. Remember, we are still following the same thing: enthalpy of formation of products minus enthalpy of formation of our reactants. So we get the ones for the products minus the ones for the reactants. So if I've pressed the calc right, I believe, okay, I think this is minus, which is a plus. So we shall have plus instead of minus. So the actual answer is minus 890.7 kilojoules per mole. So that will be the enthalpy change of combustion of 1 mole of methane. So this is enthalpy change of combustion of 1 mole of methane. Let's look at another example. We want to find the heat change of the reaction. So we want to find the enthalpy of the reaction. We have been given the following heats of formation of ammonia, water, and nitrogen dioxide. So enthalpy change of the reaction will be equal to, still remember we are following our equation, enthalpy of formation of products minus enthalpy of formation of reactants. So our products, we have twice the enthalpy of formation of nitrogen dioxide plus 3 times the enthalpy of formation of water. Then this will be minus the enthalpy of formation of our reactants, which is twice enthalpy of formation of our ammonia, then plus 7/2 enthalpy of formation of our oxygen. Feel free to pause the video and try to complete it from here and see what you obtain as I give you a couple of seconds. Yes, so obviously enthalpy of formation of oxygen being O2 in its standard form, this will be 0. So we shall be remaining with twice enthalpy of formation of nitrogen dioxide, which is 33.2, then plus 3 times enthalpy of formation of water, 285.8, then minus twice that of ammonia, which is negative 46.1. So we shall get, here we shall get 66.4 plus 3 times negative 285.8, which is negative 856.5, then 2 times negative 46.1, which will be negative 92.2. So we shall remain with 66.4 plus negative 85.65, then plus 92.2. So the answer becomes negative 697.9 kilojoules per mole. So this will be the enthalpy change of our reaction given the enthalpies of formation. Feel free to let me in the comment section the challenging aspect in these kind of questions. Don't forget to like, share and subscribe. Stay well.